Hello guys, hope so all of you are doing great. Today we'll be looking at Titanic dataset and how I was able to deploy it using Google Collab. Okay, so I use Google Collab and Streamlit for this basically this end-to-end implementation, and I'll be showing you how I did it. Okay, first of all, let's look at Titanic dataset and how I did basically how I applied a model here, why I selected a model here, and basically why I think that whichever model or basically whichever algorithm I've selected for my model is a good choice. Okay, so as you know that first of all we have done just a very simple thing. We have just imported all the libraries that we needed. Okay, then I just firstly imported this data set here. Okay, this is train.csv, test.csv. So it's a very common problem. If you can see there, like Titanic dataset is a very famous dataset. If I can just show you also in Kaggle itself, it was taken from a competition where we have to just predict that whether the person will survive or whether the person have survived or not. Okay, through machine learning. Okay, so this is that data set. You can also download it from here, and you can also start submitting predictions here. Okay, now after importing this train.csv and test.csv, the next step that I did was I just checked the shape of it. Okay, so basically to know how much basically how many features are there and how many rows are there. Okay, here I was able to see that I had some null values in basically age, and in cabin I have around 77% of null values, which is too much. Okay, these many null values cannot be handled. Okay, so we can just directly drop this cabin because this is not of any use. Okay, and we will convert age null values to some basically mode mean or something like that. Okay, now you can see that I first plotted this box plot to see if there are many outliers there. So you can see that age does not have that many outliers. Okay, so the max value that of age is basically around 80. So it is okay, it is fine. 80 is not an outlier itself. 80 can be the age of a person, right? So I then after knowing that we don't have many outliers, I am assured that I can use mean to basically replace the age. So I use mean values to basically replace the age null values. Okay, similar, and I did this for both of the test data and train data. Okay, and then I have just I think dropped after this part I will drop the cabin also. Okay, then I just checked basically I just used describe to basically know some basic information like what is 25 percentile, what is 50 percentile, what is 75 percentile. All this information we can see from here. Okay, okay, now I checked how the box plot of fair looks. Okay, so I was able to see that there were too many values that were actually beyond the outlier area. So 500 is an outlier, right? But why it cannot be why it is not a right thing to basically see this box plot here? Because see, fare is nothing but the ticket value, right? How much the ticket actually costed that person. So fare values can differentiate depending on how many families are coming or maybe what coach they are in basically. So we don't actually, so that's why I did not consider this plot as an like right thing to do. What we could have done is we could also basically plotted fare versus survival ratio. Okay, that could have been a better thing to plot here, but don't worry, we'll see it in later on. We can convert, then I just converted fare into high pairs, low pairs. Basically I see the fare was a continuous value. If I can just show you also. Okay, so if you can see, the fare was in this format, okay, numerical format, and there were too many values that were different. So obviously instead of using this as a numerical feature, okay, because if we are going to use this we need to actually basically divide it into some categories. Okay, so I did the same thing so that we can get better results. Okay, so that's what I did here. I just used pd.cut to basically cut fare into 4 parts. Okay, so you can also convert this by yourself by using pd.intervals, but I did not actually did it by myself, I thought that it would be better to basically cut directly into 4 parts. Okay, so this actually cuts the fare to 4 parts, and then I just saved it in a new feature name, which is fare band. Okay, so I created a new feature fare band and I saved these values of x in there. Okay, then here I was able to change the labels, which were nothing but these values, okay, into low, middle, upper middle, high. So these category names were actually now changed to low, middle, upper middle and high. Okay, so this was how I was able to basically create a fare category. Okay, so after doing that, as you can know that we don't need fare anymore, because we have this information now, which actually contains the information that we need, that essence of information, and we don't need this feature now. Okay, so I removed it in later on in the other steps. Okay, so you can see that again here I'm doing some just basic, I'm just looking into the data set, how it is looking. Okay, you can see that I was able to check all the data types. Why I did this? Because see, sometimes it happens that we have some data set which are not in a proper data type. Okay, so that we need to always get fixed first. Okay, and also we don't need passenger ID, we don't need, okay, we don't need a name. Okay, and these features are not necessary, so we will remove it later on. So here you can see that I have again did this for test dataset. So I just created the fare band for test dataset here. Okay, I just did use PD or interval index, okay, to basically get the bin information here. Okay, then I just used bins to basically say that cut into these value sets. Okay, and then I just again changed the, or again just added these x1 values into the fare band feature. Okay, here, and after that I just used fare category as my another feature and basically saved these values so that we can mark it as low, middle, upper middle, high. Okay, and yeah, that's what it was like. It is all that we did here, and after that we just dropped this because we don't need fare band anymore. And you might be thinking why I did not replace fare band itself. See, I thought that I will be using fare band, but then I thought that it won't be necessary because I have fare category now. So I just wanted to see that whether everything was right or not. That's why I created another feature and did not replace all the values in fare band itself. Okay, and yep, after that I just dropped fare band, fare name, passenger ID, which are unnecessary features. Okay, I have also uploaded this whole notebook into Kaggle also. I'll show you the link also. Okay, similarly I have dropped from test dataset also, and now I'm just seeing the dataset itself, like the head of it. Okay, and after that, as I had told you that I will drop the cabin feature because it has 77% null values and this cannot be treated, so I'll just drop it. Okay, simple as that. Okay, now I have also dropped ticket because again this was not actually going to be a good feature to have, but because of its there was too many values, there were too many unique values, and it actually does not giving that much information. But what could have been done, that we could have taken ticket as in like the first values of ticket, or maybe we could have seen that like what values are there in ticket itself. Okay, that would have been better if okay, because we can take these values from here also. But the problem with that was some tickets were like A/5, some tickets were like 113, so it was very difficult to actually find out which tickets were actually a premium ticket and which tickets was just a normal ticket. Okay, what we could have done is we could have also grouped the ticket with the fare category. That would have been I think a better idea, and we could have taken all those values with fare category as lower base ticket, the category where fare category was basically upper middle, the premium ticket. So we could have done that, but this would have taken much time, and I thought that it won't be that much beneficial in basically our final assumptions basically, or basically our final model training. So I dropped it. If you want to do it, you can try it out yourself. Okay, then I just used again I just plotted a box plot just to check if there were some any values. Okay, any outliers or something like that. I just wanted to check that after doing that, basically after converting null values to mean values, was there any big impact on the age itself. So no, it was okay, it was fine. So after that, again I created a PD interval index where I just selected 0 to 19, 19 to 40, 40 to 59, 50 to 80, basically 59 to 80 as my basically they are tuple values, and here I was able to basically set up bin values for cutting. Okay, so it will cut age into these many parts. So 0 19 will be one group, then 19 to 40 will be one group, then 40 to 59 will be one group, and 59 to 80 will be another group. And then I just renamed the categories as teenage, young, adults, senior, and again saved it. Similar to what I did in fair category, I did in age category also, because again this is a regression. Basically this is nothing but numerical values, and it is a continuous value, so it is better to create features from continuous value to values which are actually making more sense and actually providing us better results. Okay, see, continuous values actually make machine to confuse, and these are difficult to encode also. Although age is not needed to be encoded, but it will create some problems in basically getting better results. Okay, that's why I created this age category, and it's also seen also that doing these type of feature creation would help you actually get better results. Okay, and again I did this for test data also. And similarly after that I dropped the age band and age basically from here, test and train data set. And now we have these type of things. Basically we have a fair category, we have age category, we have embarked, we have p-arch, we have sibling. So basically SIBSP is nothing but sibling. And then we have sex, we have male, female, p class, survived. So these were all the things that we actually needed, and then we just went ahead and started encoding these. So before encoding, as we know that we should always do a train test split, so that it helps us to basically reduce the data leakage, chances of data leakage. Okay, and then I just created these vectors. So x is our matrix and y is our vector. So x contain the basically the first, leaving the survive, it has all the data set because survive is our dependent feature, and y is equals to basically survived, basically this is our independent feature. Okay, and then we actually did the train test split, so basically to able to check in later stages to basically see if our score is actually good or not. Now here many people actually do this, they actually don't do this step train test split, because if this is a Kaggle competition, they just go ahead with actually checking the score and just start to give it. But this won't, if you are checking the score without actually doing this step. Okay, what happen is that you are actually not knowing that whether your model is overfitting or not. Okay, and that can be a problem sometimes, because we think that our test basically train score are good, but sometimes this does not works that good. Okay, sometimes your model is actually overfitting, you are getting a very very good result, but that is not the true scenario. Got it? That's why I did train test split, so I can also check it with test dataset also, where we know the y values. Okay, again I just checked what we have here, and then I started encoding it. So I encoded female as 1, male as 2. Okay, simple label encoding, or you can say ordinal encoding. Okay, again I have done the same thing here also in embarked, and also in fair category and age category, as these are very simple value, I did the same thing. I did the ordinal encoding. Okay, simple. What other encodings can be done? We can do main target encoding. Okay, we could have done frequency encoding. Okay, that's up to you, you can use it if you want, although this will work fine. Okay, this is like both of them are almost same thing. Okay, now after that, before actually selecting my model, it is a very good practice to check your pair plot. Okay, now pair plot is an amazing thing. Okay, you can all see that all the features based on the survive dataset. So I have converted hue is equal to survive, so now we can see that how all these features are actually interlinked. Okay, so you can see that there are not many overlappings here, right? and there are few features which are actually overlapping. So what we can do is we can use three algorithms here. Okay, number one, the decision trees, because they are they are exceptionally well in handling many tasks. Okay, and I don't know why, but decision trees are actually the go-to solution for almost all the machine learning problems. But obviously we need to do some EDA to actually get into that point. We cannot just go ahead and use random forest or use any decision tree algorithm like XGBoost or maybe ADA boost. So we need to do some EDA before actually getting to a conclusion. But again, I actually checked this. So basically we could use three algorithms here. The number one, if we consider these types of points, okay, what we can see is there is some amount of overlapping that is going on here, especially for these type of categories, right? So because of that overlapping, we can use k nearest neighbor to basically solve this problem. But again, there are features that are separated with a good amount of value, but still they are basically getting overlapped here, you can see, right? So because of that, logistic regression should not be a good choice. And also you can always check it out by using by directly going and applying that model and seeing if you are getting a score good or not. Okay, and you can just do this for 2 or 3 models. Okay, right, you can do that. But obviously, see, if you have a very big data set, suppose 1 million records, like in a few days I'm going to create a video with a very big data set, and I'm going to do all the things similar to this video. I'll be doing EDA, I'll be deploying it. Okay, if you're doing that big of a project, then it will be very difficult for you to actually deploy, like actually do basically model training again and again. As it will take you a very sincere amount of time. So instead of that, what you can do is you can just use this pair plot to actually understand which model would be best for you. So obviously, by seeing this pair plot itself, I can understand that I can use two algorithm that would work really great. Basically, one would be the decision trees and one would be the k, and basically the nearest neighbor. Okay, k nearest neighbor. Why? Because you can see that there is overlapping, right? So we can use k nearest neighbor here also. Now, after knowing that information, I just went ahead and basically I used k nearest neighbor classifier, k neighbors classifier, to basically see how my accuracy and score are actually coming out. So you can see that for a test dataset it was around 79, and for train dataset it was around 83. Okay, that's why I told you. See, we are getting a good score for train and y train, but we are not getting a good score for x stat, y stat. And this is called as overfitting. Okay, although it is not that much overfitted, it is okay, it is fine, but still I'm telling you that if you actually use, especially in decision trees, this is very common to get faced with such problems. Okay, although there are some exceptions like XGBoost which can handle overfitted data very well, but you should first do you should always basically try to do train test split. Then I just plotted a ROC curve to see how much area under the curve we are getting. Okay, and we are actually getting 0.77%, as you can see, or you can see 77% here. Okay, so this was actually what we did. Then I checked the classification report to basically know about precision, recall, F1 score, and all these values. For those who don't know what is precision, what is recall, see, understand this. Precision is nothing but basically total positive by total positive plus false positive. Okay, recall is nothing but total positive by total positive plus false negative. Okay, so this is false positive, this is false negative that is considered here. Okay, now in this scenario, or we can just use F1 score also. So basically we will consider these value as a very important value, like 8.85 is actually telling us that we have a good. You should never actually consider accuracy, especially when if you're actually working with a classification problem where there is some type of, like, suppose if see, if there is a basically, let's say, situation like cancer. Okay, you should always check that you are not getting a higher amount of basically precision value than recall value. Why? Because if you are getting a higher amount of precision value and not good amount or not higher amount of recall value, okay, what that actually signifies, that means that you are getting basically you are getting basically your model is actually predicting, suppose someone has a cancer, it is predicting that it does not have a cancer, which is very dangerous thing in a medical statement, right? If a person is actually classified as it is not having a cancer, even though he is having one, that means he would not try to go and check do a checkup for that, right? And if he has a cancer, he can die also. So this is a wrong thing. What we want to do is we need to increase the recall score, so that if a person, even though if you don't have a good precision, that would work, okay, that is fine. But if we have a good recall score in that scenario, what that means is that if that person does not have a cancer and our model is predicting that it has a cancer, even though our model is predicting wrong, that person can go and have a checkup it for itself, okay? That would do no harm for him, right? So that is what basically why we need to check these values. Again, I just tried and checked these type of things basically. After that, I just used random forest classifier here, okay? Now why I used a random forest classifier? Because I wanted to see how it will perform, nothing else, okay? And you can see clearly here that we got a very good score here after using random forest classifier, okay? So I was actually very much convinced that random forest classifier is our go-to algorithm now, okay? See, I actually told you, right? Decision trees are very exceptionally well with these type of datasets. Don't know why, but they are, okay? And after doing that, to increase my accuracy score more, okay, what I did is I just used hyperparameter tuning here, okay? By using randomized search CV, I did hyperparameter tuning. I created this parameter grid, okay? And this parameter grid is nothing but basically having random values of n estimators, max features, max depth, minimum sample. If you don't know how actually I was able to find these things out, it is very simple, guys. You don't have to do many like you don't have to go anywhere. Just see shift tab and you can see that all these parameters are there, right? You can actually tune them using hyperparameter tuning and randomized search CV, okay? In randomized search CV, and this will actually do things for you. Scoring is equal to accuracy because this is a classification problem. If we are having something like a regression problem, then this will be negative mean squared error, okay? Simple, because we don't check accuracy in basically our regression problem. We use negative mean squared error as our scoring parameter. Now hope so you get it. Basically this is what we did. N iteration means 10 iteration, n jobs mean nothing but the processor, so it will use all the processor. CV is equals to 5, cross validation. So these are all the verbose is equal to 2 is nothing but it is for basically showing these things. Basically this how it is working, nothing else, okay? If I just remove it, it will not show me all this information. Now estimator is our model, okay? Simple. We use randomized search CV. I saved the information in random RF, and after doing the fit, we were able to basically we have just optimized it, okay? So if I check my values now, okay, what will happen? Okay, as you can see here, random RF score X train Y train was somewhere 8469, okay? What were we getting here? We were getting somewhere around 86. Now you might be saying that it has dropped, right? But see, understand it in this manner, that here what we are doing is we are getting some score. See, 84, 81, right? Understand this. This is a very important thing to understand. 84, 81, okay? 81, 86, okay? 81, 55, 81, 55. Why we have dropped basically why our accuracy actually dropped? Because see, this means that our data was getting overfitted at that time, okay? But it actually now was able to get it in a proper place, okay? Now what we can do is we can just select the best parameters from here, okay? Like I have by using this command here, and these are my best parameters that are actually giving best accuracy, and we can select this parameter in our random forest classifier, okay? In this manner, I have just selected here, you can see, okay? We can again do some tuning and all to basically see if the results are okay or not, and then you can see we can just use them, and actually it will give us a better result, okay? Better accuracy, okay? Yep, and that was how I actually did it. So I was actually getting more accuracy. I don't know why it is showing this thing here. I actually got somewhere around 82 in accuracy, but I think I have done something. Okay, so you can see that my accuracy is somewhere around 81. Okay, which is improvement from the previous classification, if you can see here. Right, which is a pretty so let me just show you. Give me a second. Okay, let me just do it without anything. So we are getting somewhere around 81. Okay, right, after using the best parameters from here, this was random RF score. Okay, this is not the actual score, this is what our actual score was. Okay, and that is how you actually do the hyperparameter tuning to basically increase your accuracy. So I am getting somewhere around 81 accuracy here and 84.97 here again. So okay, it's okay. Alright, no worry. Right, we can just print a classification report. So we are getting as 86 as our FN score, 81 as our accuracy. And now I just use these parameters here. Basically N estimator as 200, max depth. These are my best parameters. Okay. And we are getting a low accuracy. Don't know why this is happening. Let's just go with 300 now. Okay. Have I done something wrong here? Max depth is 15. I think max depth 10 would be better. Although it is saying 15, but So yep, we got till 0.81. That's fine, it is not that much important. Okay, so you can see that basically we did some hyperparameter tuning here, and then we just basically did all these things. Okay, so that's how you actually approach a problem. Okay, after that, to basically deploy this project, what I did is I created a pickle file here. Okay, I created a pickle file here. Okay, in write byte mode, and I actually uploaded this file into my drive. Okay, after doing that, I actually used Google Collab to deploy this project, and you can see I have created this amazing notebook for you also. You can see this notebook. Basically, I'll upload, or I'll just add this link in the description itself. You can see that I have created this notebook. You can also see here that this is the notebook for actually this problem. Okay, and yep, this is the whole notebook, right? I think I used this random forest classifier here, that's why I was getting some bad score at that time, maybe. I was getting almost pretty much similar score. I don't know why I'm seeing such thing here. Although I was able to get a better recall value here. That's fine. Alright, here I am getting best parameter as 700. fine. This don't worry about that. Okay, so you can see this, you can reference this notebook also. You can also try hyperparameter tuning by yourself also, by actually changing some of the information that I have, or actually increasing some information that you want to increase in the parameters itself. But that is how you do hyperparameter tuning for the random forest. Okay, now here you can see that I have deployed it using Streamlit. Okay, and Streamlit is a very amazing framework, I'll say. It is like for deploying such and doing such tasks, this is a great thing. So I have also mentioned how to basically run these things, basically run this. You can actually share these CVs with people also, basically share these notebooks, okay, for with people also. So here you can see that you just have to do a pip install here first, okay, for the first startup. Because see, this Google Collab actually get disconnected and then it gives you another Linux system, okay, by relocating your data, and that actually deletes all the file from here. So to basically recreate those files, you need to actually follow these steps to basically do that, so that you can actually see the program running. Okay, and this is the step 2. This will be this actually write this file, okay, and this is actually the Streamlit file, or you can say that this is the Streamlit. This will create a Streamlit application. Okay, so you can see that I am using don't worry about this, because this was what I was testing it out. I was trying to basically see how it was actually working. So this is what I write first, and then I just change it to a single line code. Okay, and after running this, you can see that if I refresh the data, app.py will be created here. Okay, now, and this is the final step. I have also mentioned what things you will see here. Now here we are using local tunnel. Okay, local tunnel will actually help us to basically get a URL like this, okay, where we can actually see how this thing is running, and it gives a warning. So I have mentioned also that just ignore the warning and please click continue, because local tunnel can be used by some hackers and people who actually try to do phishing and all these things. So that to basically save yourself from this, there is just a warning, but you don't need to actually see that warning. You can ignore that. Okay, so after doing that, I'll just run it and I'll show you how it looks. Okay, this is the application that I have created with Streamlit. Okay, and Titanic dataset itself. It takes some time to load in the first instance. Okay, see, now we can just add the values here, like 1, okay, 2, 1, maybe 1, and all these values will be numerical, because as we know that we have actually did that. You can also check the information of elements. I have actually like created this thing to basically, so basically you can see that how it is actually divided, like C is equal to 1, S is equals to 2, Q is equals to 3. Okay, and what is port of embarkment? C is equal to Cherobor, Q is equals to Queenstown, S is equals to Southampton. And see, that is why I love to use Streamlit in these type of projects, because see how easy it was, right? If you want to do same thing into basically any other site, then you have to actually deploy it using AWS and all these things. But using Streamlit, you can directly deploy it on your Collab, right, in just few steps. You could also use Flask, but Flask actually does not support creating these type of HTML pages. You need to create an index file, and then that index file is got to be created in similar fashion. So that would increase our step, and I don't want it to do that, and I thought that this would be better. So you can see that if I just predicted, it will tell me if the person was able to survive or not. So person not survived. Oh, that's bad. So hopefully you liked this video. Please subscribe to my channel if you want to see such type of videos. I'll be creating more notebooks like this. If you want to basically check out this whole Collab thing, you can also go here. You can go to my GitHub profile, and you can see that I am actually giving you a link here. Okay, I'll be including all the links here. I am working on my GitHub profile also. Hopefully you liked my video. Subscribe to my channel and stay tuned for coming videos. Thank you. Bye bye.